Section 8.4 is polynomials. So a polynomial is a monomial or a sum of monomials. So we all know what a monomial is. We've been working with those. So 3x is a monomial. And then if I do a sum of monomials, like 4x squared y plus 7x squared plus y, that's 3 monomials. Another word for monomial is term. So I have 3 terms. Each term is a monomial, and so therefore this is a polynomial because it's the sum of 3 monomials. So tell me how many terms in this monomial, or in this polynomial. 2x plus 3y squared plus 7 plus x squared. So how many terms are there in this one? Good, there's 4. 1, 2, 3, 4, all added together, the sum of monomials. How about this one? So the question is, does this count because it's subtraction? It does, but let's talk about this. Here, in this one that we just did, the terms are 2x, the next term is 3y squared, the next term is 7, the last term is x squared. Each of those terms is a monomial. In this one, we have to be careful because it says it's the sum of monomials. However, I can rewrite this as plus a negative 1. So the first term here is 3x. The second term is negative 1, not just 1. That's why we talk about how important it is when you rearrange the order of terms that if there's a negative sign, it stays as part of that second term. Okay, so a polynomial again is either a monomial or a sum of monomials. Okay. Classifying polynomials by number of terms. So I've talked about that a little bit. So if we have one term, it's a monomial. 2 terms is a binomial. Bi means 2. 3 terms is a trinomial. Anything after that, 4 or more terms, we just call by the general term polynomial. So we can use polynomial for all of these. These are all polynomials, but these are more specific terms or more specific words for 1 term, 2 term, and 3 term polynomials. So what would you classify this as? I hope we could all tell you that that's a monomial. How about this one? 3x squared plus x minus 1. How many terms? 1, 2, 3. The first term is 3x squared. The second term is x. Don't forget the third term is negative 1. So this is a trinomial. Okay, monomial, trinomial, and let's do a binomial. 3x plus 7 is a binomial. And again, I can also call these polynomials, but it's a less specific term, and anything 4 or more is just going to be polynomial. We're not going to bother to count them up. So that's classifying polynomials by number of terms, being able to tell how many terms. The second thing we're going to do is classify by degree. Now the degree of a monomial is the degree of the highest term. So let's look at a couple single terms and see what their degree is. 3x squared is a second degree, and this also happens to be a monomial. All right, 4x squared y, the power of x is 2, the power of y is 1, so this is a third degree. So we're adding up the powers of the term. Now we have to be careful because the degree of a polynomial is the degree of the highest term. So once I have a polynomial like 4x cubed plus 2x squared plus 3xy, I'm not going to add up all the powers. I'm going to find the highest term. So this is a third degree, this is a second degree, this is a second degree. So the degree of the entire polynomial, those are my degrees, the degree of the entire polynomial, this polynomial is a third degree polynomial. And some of these have special names also. I'm going to go ahead and erase this. Your book doesn't use these, but I want you to become familiar with them. So a 0 degree term is a constant. How can we have a 0 degree? Well, 4 is a 0 degree because the variable, if it was an x, would be x to the 0 power because that equals 1. So in other words, there are no variables, so the power of the variables is 0. Another word for that, as I said, is a constant. So any constant, 4, 17, negative 235, these are all 0 degree constants. A first degree is a linear equation. You have seen linear equations in the form of mx plus b. Again, the term of this polynomial is the term of the highest power. The highest power is first degree. This term is 0 degree, so the entire polynomial is first degree. Second degree is called quadratic. We're going to be working on quadratic equations very shortly. And then after that, we're just going to call it by the degree number. So third degree, we just call third degree. Fourth degree, just call it fourth degree. We don't have any more special names. There are some, but we're only going to worry about these three. And as I said in the book, you're just going to classify by the numeric value of the degree. So you're just going to say 0, first, second, third, fourth, etc. But keep in mind that these words are ones that we are going to be using together. Okay, so let's talk about classifying by degree and number of terms. We always say the degree first and the number of terms second. Think of it this way. If you're asked to go out to the parking lot and classify the cars in the parking lot, and I ask you to classify them two ways. One, by the manufacturer. Is it a Ford? Is it a Volvo? Is it a Lamborghini? What is the kind of car? And second, by the color. So is it red? Is it white? Is it silver? What's the color? So those are the two kinds of ways. If you found that there were 6 cars that were yellow and built by Toyota, you wouldn't say there are 6 Toyota yellows. You would say 6 yellow Toyotas. So we do the same thing here. We also say the degree first and the number of terms second. So if we have something like 6x squared y plus 4x minus 2y plus 7. The first thing I have to do is find the term with the highest degree, and it would be this one here, and the degree here is 3. Then I count the number of terms, 1, 2, 3, 4. So this is a third degree polynomial. Okay? 7x to the 8th plus 4x squared minus 2. Again, the highest degree is here. It's an 8th degree. So this is an 8th degree. And how many terms? 3 terms. So I'm going to call it a trinomial. Okay. We'll do one more. 2x squared y plus 3 x to the 4th y minus 7 x to the 8th plus 2 y to the 15th. So we need to find the highest degree. This is a third degree. This is a 5th degree. Remember, I'm adding up the powers within the degree. This is 8th and this is 15th. So that's my highest power. So the entire polynomial is a 15th degree, and 1, 2, 3, 4, too many terms for a special name, so polynomial. Okay? So I want you to now arrange the polynomial in ascending order using the powers of x. Ascending means smallest to largest. So if I give you this polynomial, and it is we'll go ahead and classify it and then come on back. So let's see, that's fourth degree, second, third, third. So this is a fourth degree polynomial. And I want to arrange it in ascending order, the smallest x power to the largest. So the smallest x power is the term that only has an x to the 0, no x's at all. So that's my first term. The next smallest is the x term, where the x has the power of 1. Then there's the negative 3x squared y. Notice how that negative sign goes with that term because this is really plus a negative. So minus 3x squared plus 5x cubed. So the x's are in ascending order from lowest to highest. It doesn't matter what the y's are. It doesn't matter that this term is the largest degree term. If I'm ascending using powers of x, I just look at the x's to decide which comes first, second, third, and fourth. Okay, and what if we wanted to arrange with descending power? So 6x squared y cubed plus 4x cubed y minus 2x to the fourth y cubed plus 7 plus 4x. So I want the highest power of x first. So that would be this one. It has a negative in front. Bring it with it. Next highest x power is for x cubed y. After the x cubed is the x squared, the one in front. Then the x, and then the constant. So again, descending order using the powers of x. So that's it for today.